Okay, 7.2 is on geometric sequences. Okay, um, it's a little different than what we did with the arithmetic sequences, but similar at the same time. So we're going to see recursive and explicit come up again, but we're going to write them slightly different. Okay, so what is the difference between an arithmetic and a geometric sequence? Geometric sequence has a constant or common ratio instead. So the common ratio is the constant ratio of any two consecutive numbers in a geometric sequence. Meaning, if I give you the sequence 1, 6, 36, 108, right? If I gave you this sequence, right? What do we see happening here? We're multiplying by 6 to get the next term, right? But what happens is this multiplication of 6, right? That is our common ratio. So our common ratio here would be 6. So it's a number you're multiplying by over and over in the pattern. Okay. So that gives us, when we have a common ratio, that gives us a geometric sequence, which is a sequence of numbers in which the ratio, right? And anytime we see ratio, we're talking about dividing, of any two successive terms is equal. Each term can be multiplied by the common ratio to produce the next term in the sequence. And that's kind of what I talked about up here. Okay, and a sequence is an ordered pattern of numbers. So up here, like 1, 6, 36, 108, another geometric sequence that you might see is like 3, 6, 12, 24, 48, right? Where each time, right, if I look at this, if I do 6 divided by 3, I get 2. 12 divided by 6 is 2. 24 divided by 12 is 2. Or I can look at it as I'm multiplying by 2 each time. Okay, so next, so up in the box here, they give us, 3 sequences, and we need to determine if they're geometric or not by determining if there's a common ratio. So remember, when we look for a common ratio, we're looking for, are we multiplying the number by its same each time? So in this case, 1 times 3 would give me 3, 3 times 3 would give me 9, 9 times 3 would give me 27. So the common ratio is 3. Is it geometric? Yes. The next one, I would multiply by 2, right? Multiply by 2, multiply by 1.5. Is that geometric? No, right? There is no common ratio here, right? Therefore, it's not geometric. The next one, multiply by 5, by 5, by 5. So the common ratio would be 5. And yes, it is geometric. Summary, right? When the blank of the terms in a sequence is a constant number, the sequence is a geometric sequence. Okay? Now, when we talk about this, right? When the ratio of the terms in a sequence, meaning is a constant number, meaning if I take the next term and divide it by the previous term, I'll always get the same number. That's what they're saying there when we talk about a ratio. So how to find the common ratio of a geometric sequence, right? So basically when we look at it, you can either do one of two things. You can see what you're multiplying by each time, or I can take the new term and divide it by the old term. 10 divided by 2, I could do 50 divided by 10. So we're taking the new term, 250, and dividing it by the old term, 50. And do you get the same number each time? Yes. So the common ratio is 5. Now here, right, when the numbers start big and go the other way, what I have to look at is, right, what am I doing to get 81? What am I doing to get 27? What am I doing to get 9? When I work this way, right, I am dividing by 3, dividing by 3, dividing by 3. Or think of it this way. What is your new term, 80 or 81 divided by the old term, 243. So that would give you 1/3. Or if I take 27, my new term, and the previous term was 81, when I take that, what would this become? 1/3. If I take my new term 9 divided by the old term 27, I would get 1/3. So the common ratio here is 1/3. Okay, so if you're going up, you're multiplying. When you're going down, you're dividing. All right. So looking at here, how to find the next term in the geometric sequence, right? When I look here, what am I multiplying by here? Right, multiplying by 2, so the common ratio is 2. But now it says find the missing number. So here, if I have 3 to 6 to 12 to 24 to 48, I know my common ratio is 2, so the quickest way to find the next term in the sequence, 48 times 2, is 96. All right. So now we got to talk about this recursive formula. And remember, the a sub n value of the term in the sequence, right? What does that mean? That's like the nth term. Okay, so this is the nth term of a sequence, right? The value of, so a sub n minus 1 is the value of the previous, right, term in the sequence. And r is what we call that common ratio. Okay, so basically we're going to say a sub a number equals a number, right? So we're going to state the first term in the sequence, and then we're going to say a sub n equals, we're going to take the previous term and multiply it by that common ratio. All right, for example, when I look at this, right, 2 to 6, 6 to 18, 18 to 54, what am I doing each time? I'm multiplying by 3. So my common ratio r is 3. What is the very first term? My very first term is 2. So when we write our recursive, right, our first term, a of 1 equals 2 is the first thing we start with. And then we say the nth term is our common ratio times our previous term, which is a sub n minus 1. Okay, and when we look at the fifth term, all we're going to do is take 54, we're going to multiply it by 3. So 54 times 3, you get 162. So the fifth term would be 162. Now the next one, we go from 1/2 to 1/4, 1/4 to 1/8, 1/8 to 1/16. All right, what are we multiplying by each time? We're multiplying by a half each time. So we start with the recursive formula. We start with our first term. A sub n equals 1/2. Therefore, a sub 1, sorry about that, our first term. Then a sub n is 1/2 times a to the, or sub n minus 1. When we look at the fifth term, what is 1/16 times 1/2? That would give us 1/32. All right. Now the explicit rule, right? A sub n is the value of the nth term, we say, and a sub 1 is the basically the first term in the sequence, right? Or what I like to call it's the first term in the sequence, or I like to call it the initial amount. Either way you look at it, it's the same thing. N is any term in the sequence, and R again is that common ratio. You have to know how to distinguish the difference between an explicit and recursive rule. Okay, so let's look at this. First thing I do is I find my common ratio, right? Which is 2 times 3 would give me 6, 6 times 3 would give me 18. So my common ratio is 3, and my initial value is 2. So we say a sub n equals my initial value 2 times 3 to the nth power. Okay, so if you look up here, right? Oh, sorry, excuse me, they go n minus 1. That's right, because it's the previous term. Okay, so what would the 10th term of this be? Well, we say a sub 10 equals 2 times 3 to the 10 minus 1, which gives me 2 times 3 to the 9th. It's going to be a pretty big number, right? If you plug that in the calculator exactly the way you see it, right? 2 times 3 to the 9th power, we get 39,366. Okay, when you look at the next one, right, what am I multiplying by each time here? I'm multiplying by 1/3. So my common ratio is 1/3. My first term is -1. So we say my nth term is going to be -1 times 1/3, my common ratio, to the n minus 1 power. All right. Now when I go to find the 10th term, I'm basically going to do a sub 10 equals -1 times 1/3 to the 10 minus 1, which becomes -1 times 1/3 to the 9th power. And if you put that in the calculator, you will get 1 over 19,683. Okay. So now it says here, the recursive formula for the geometric sequence is the following below. What is the explicit rule? Remember, to write the explicit rule, you need the first term and you need the common ratio. So in the recursive rule, you know your first term and you know your common ratio. So we're going to say my explicit rule, a sub n equals my first term -2 times my common ratio 1/3 to the n minus 1 power. And we are done. Okay, so it's knowing what you have to have in order to get here. So now the explicit rule for the geometric sequence is given, right? What is the recursive rule? Well, when I look here, this is your initial amount, A. This is your common ratio. So when we go to write the recursive rule, we're going to say a sub 1 equals 1/2. Then my nth term is going to be my previous term times 1/2. So, or sorry, times 3. So we go 3 times a to the n minus 1, or sub n minus 1. Okay, and that is the recursive formula. All right, let's quickly go look at the checkup problems. All right, so the common ratio for this first sequence, right, is going to be 3, right, times 3 times 3 times 3. So my common ratio would be 3, okay? What they also want you to see is you can take your new term and divide it by your old term, and you would get that common ratio. The next one, I'm going to take my new term, 125, divided by my old term, 625, and when I reduce that, I would get 1/5. So my common ratio here, R, is 1/5. Now number 3 says, is this arithmetic or geometric? But when I go from 5 to 10, 10 to 15, 15 to 20, 20 to 25, am I adding or multiplying the same amount each time? When I look, 5 times 2 is 10, but is 10 times 2 15? No. But if I do 5 plus 5, right, gives me 10. 10 plus 5 gives me 15. 15 plus 5 gives me 20, right? If we're adding the same amount, that means it has a common difference, which means it is arithmetic. Okay? So they want the recursive rule for this geometric sequence. So remember, I need my first term, so a sub 1 is 100. Then I have to look, what am I doing each time here, right? 100 to 50, 50 to 25, I'm dividing by 2, which is the same as multiplying by 1/2. So we're going to say a sub n equals 1/2, because that's what I'm multiplying by each time, times, right, my previous term. And that's your recursive rule. A sub n minus 1 is the previous term. So what is the recursive rule, right, or explicit rule? So this is the one where I find the common ratio. I'm multiplying by 4 each time. So my common ratio is 4. My first term is 7. So we say a sub n is equal to my first term 7 times my common ratio to the n minus 1. Okay? So the next one, a geometric sequence has an explicit rule just like this. What is the fourth term? So we're replacing n with 4. So a sub 4 is equal to negative 2 times 3 to the 4 minus 1, which is going to give me negative 2 times 3 to the third power, which now gives me negative 2 times 27, which is going to give you negative 54, would be the fourth term in the sequence. Okay? Now this is the weird one. The number of players in a tennis tournament is reduced by 50% after every round. In round 1, there are 256 players. Round 2, there are 128, and so on. What is the explicit formula? Well, we know a sub 1 is equal to 256, and if it's cut in half, or 50%, we know our common ratio is 1/2. So our explicit rule would be a sub n equals our initial amount, 256, times my common ratio to the n minus 1 power. So how many players would be left after round 7? So a sub 7 equals 256 times 1/2 to the 7 minus 1, which is 6. And if I go and evaluate that in my calculator, I would get there'd be 4 players left after the 7th round. Okay. Now, if the geometric sequence has this explicit rule, right, what is the recursive? So from here, I know this is my a sub 1, this is my common ratio. So if a sub 1 is 13 and my ratio is negative 2, then I know right away a sub n, it's recursive. So we say a sub 1 is 13. Then a sub n is equal to my common ratio, negative 2, right, times my previous term, a sub n minus 1. But then if you're given the recursive rule, how do we write the explicit? Well, we know our first term is 2, and from the recursive formula, this is my common ratio. Therefore, I could say a sub n is equal to my first term times my common ratio, negative 3, to the n minus 1. And I'm done. All right. Go ahead, try the quiz, and send me your score.